Yes, good evening, guys, to all of you. Once again, I welcome you all on this wonderful platform that is BYJU'S exam prep. So, in the morning, we have seen some wonderful concept of theory of machines, and now we are here to complete that with a practice session. So, in this practice session, we are going to see yes, Ajay, Raghu, Sri, Arvind, hi dear. Yes, Teju. Good evening, it is. So, guys, in this session, we are going to see the question from simple mechanism, the question from velocity analysis, the question from acceleration analysis, and the questions from flywheel. Okay, so we will see questions from all the areas what we have discussed in the morning. And my dear, I have taken care of one thing, that I am covering all the types of question. Okay, so every type is being covered in this beautiful session. So we are starting it. Just like and share the session. So this was the marathon we have today morning. So for that only this session is there, and this is some detail about me. So this subject is related to theory of machines. Tomorrow you can appear for a scholarship test where you can get up to 90% scholarship for GATE and ESC preparation session. Yes, Jubin, hello dear. And this is the schedule for the marathon. We are meeting again. On 12th January for vibration and for 14th January for machine design. Okay, tomorrow you are having class for fluid mechanics. Okay, so this is how the marathon will be going like. So this is the first question. Okay, you are having. This is from quick return motion mechanism. Crank and slotted lever quick return motion mechanism. This is a very important question, guys. Yes, just try to solve it and give the answer. I'm waiting for your response. Just solve it, guys. Ajay, Jobin, Jyoti Prakash, Teju, Raghu. Yes, solve it. This is the first question. We are covering everything. Everything would be covered. Every type of question you will see here. So today morning marathon session plus this practice session are a complete package. So the length of fixed link of a crank and slotted lever mechanism is 250 mm and that of crank is 100 mm. They are asking you about the time of cutting to the time of return stroke, TF by TR. They are asking you about beta by alpha. They are asking you about quick return ratio. Let us see how many of you give the right answer for this. SK is saying B, Sujesh is saying B, Ajay is saying B, Manas is saying B, Kiran, good evening भाई, बहुत बढ़िया किरण, everyone. पंकज सर सिविल की जियोटेक की क्लास होने वाली थी, लिंक है क्या? पंकज दोनों चल रही होंगी. I feel जियोटेक is also there. Okay. It would also be about to start. Maybe sir would be late by 1-2 minutes. It would also be about to start. Okay. So you can see on the channel, you will find it easily. So my dear, you would be starting with cos alpha by 2. Cos alpha by 2 can be found out as R by L. You can see the crank radius is 100 and L is 250. Okay. From here you can find out cos alpha by 2. I feel you will be getting alpha to be equals to 132 and beta would be coming out to be what? Alpha plus beta is 360. So beta would be coming out to be 227 and the ratio of beta by alpha would be coming out to be 1.709 something. Answer would be B for this. Wonderful, guys. Okay, Pankaj, then you will get from the Telegram channel of sir. Okay, there also you can find out. The second part of the same question. Here they are asking you about what will be the length of the stroke. This is also never been asked in the paper. So that is why I included the stroke length. So how you would be finding out the stroke length? I feel you are aware of the formula for stroke length. This is 2 times of LS into R upon L. Solve it and tell me the answer. Kiran have given the answer. Very good. Venu, hi dear. Teju is saying C would be the answer. Ajay is saying C would be the answer. Wonderful, guys. So answer for this would be 2 into length of slotted bar. Length of slotted bar is 450 crank radius is 100 and length of connecting rod is 250. So 0 0 will get cancel out, 5 2 ja, 5 5 ja, it is going to be 360 mm. Yes, C would be the right answer. So guys, we will not be wasting time, we are covering all the types. Okay, this is from eye center approach now. As I already said, I am not wasting the time, every type of one question. Yes, and I have included 5 questions from Flywheel because there you were having more doubts and I have taken difficult question, to be frank. Okay, so yes, good morning Sri Arvind. It's really good morning that we are studying at this time. Okay, so guys, this is from eye center approach. So we are going to have 15-16 questions from all other topic. Then at the end 5 questions from Flywheel, and they are difficult questions, frankly telling you, because you requested for that, so I have added them. Okay, especially for Teju. Very good guys. Solve the answer for this. Velocity of B is this. You need to find out velocity of B perpendicular to the direction of velocity. Perpendicular to the direction of velocity. Perpendicular to the direction of velocity. Here you will get eye center. Tell me VB. Yes. Okay, Kiran is saying Abhishek, good evening dear. Yes. So answer is, okay, what would be the answer? Some people are saying answer to be 4 and some are saying answer to be 2.25. Yes, what would be the answer? So if you will be solving this, you know that VA is given to us. So VA is 3, which can be written as AI into omega AB. Then VB we need to find out, which is BI into omega AB. You know this is given to you as 0.9 meter. They have also mentioned this distance to be 1.5 meter. Okay, this is 0.9. So by Pythagoras you can find out as 1.5 ka square minus 0.9 ka square. So once you will get, you can take the ratio of VB and VA. When you will be going for ratio of VB by VA, that will be coming out to be BI upon AI. So when you would be going for the ratio of BI by AI, you will be getting VB to be equals to, I feel 2.25 meter per second is correct. So I don't know why you are getting 4. Answer would be D for this. बहुत ही बढ़िया अद्वैत, बहुत ही बढ़िया अजय, मानस, किरण, Jobin. So Jobin, you may be getting your mistake. The answer is D for this. Okay, is it clear to everyone? Shall we move on? Everybody is clear for this. Very good, Shreyas. बहुत बढ़िया. Moving to question number 4. This is about eye center. Can you tell me what would be the answer for this one? This is once again a good question. Once again a good question. Very good, Faisal. Once again a good question. So what would be the answer for this one? They are asking about eye centers. Very good. Very good. Kiran is saying answer to be B. Teju is saying B. Okay. बहुत बढ़िया. Venu, Naveen Dola, बहुत बढ़िया. Manas, बहुत बढ़िया. So my dear, the answer would be B because it is a pure rolling motion happening, and pure rolling motion indicates rolling pair. Pure rolling motion indicates rolling pair, and for rolling pair the point of contact gives the eye center. So answer would be B for this. Wonderful. बहुत ही बढ़िया. Abhishek, बहुत ही बढ़िया. This is the one more type of eye center approach where they are giving this kind of diagram. As I said, I am covering all the types. Okay. So what would be the answer for this? Here you need to find out the velocity of C. So velocity of C can be written as Ci. Velocity of C can be written as Ci, and it is also mentioned, all the distances are given to you. This can be written as Ci into omega of BC. Okay. And you can write velocity of B to B. Velocity of B to B, AB into omega of AB, and can also be written as BI into omega of BC. So if you understand the approach properly, you can use this relation to find out omega BC. Then put this value here. You will get VC. Solve this one. Yes, very good, Sri Arvind. बहुत बढ़िया. So guys, just like and share the session. This is the 5th question we reached on to. We are going to solve more than 20 questions in this session. So I am moving with your pace. You all guys are answering nicely. You are prepared for these questions. That is the best thing. Okay. So every type is covered here. Some misconceptions would also be eliminated today. Solve it. And don't worry guys. We are coming up on 12th January. On 12th January, we would be completing entire part of tone and vibrations. Abhishek is saying A. Sujesh is saying A. Very good. Kiran is saying A. बहुत बढ़िया. Yes. Ajay is saying A. Kiran is saying A. Everybody guys, the answer will be A. So first of all, you are going to use VC as CI into omega VC. You need to find out this. But first of all, you need to find out this. AB is known to us. Omega AB is known to us. BI is known to us. You can find out omega BC. Because point B is present on AB also, on BC also. So you can find out the velocity of B from this and from this. So this will give you the value of omega BC. And once you will be putting it, you would be getting 1 by 3. So the answer is going to be A for this. Very good, Ajay. Yes. They are asking the units meter per second, but they have given the units in centimeter. So you need to divide it by 100 as well. Question number 6, guys. Here they are asking you about the relative velocity. So angular velocity of 2 relative to 3. So you know omega of 2, 3. You can write it as omega 2 minus omega 3. This is how omega 2, 3 is defined. Just solve this question as well. Omega 2, 3. So they have already given to us these two velocities, 11 and 15. So just solve it and get the answer. This is also one more type of question. Very good, Jyoti. बहुत बढ़िया. Kiran is saying C would be the answer. Yes. Shreyas, Advait, Teju is saying C. Advait is saying C. बहुत बढ़िया. बहुत ही बढ़िया. Shreyas, very good. So the answer for this is going to be C. This is 4 radians per second. So we are going to have omega 2 equals to 15. Omega 3 equals to 11. So the answer will be 4 radian per second. This is easy, but this type of question is not covered. That's why I have taken this. So this is one more type of question from pure rotation. Very good, Faisal. So 2 points A and B located along the radius of a wheel. This type of question also can come in the paper. This is the radius of wheel. They are saying that point A and B located along the radius of the wheel as shown in the figure have velocities 80 and 140. So this velocity is 140 and this velocity is 80. You know velocity profile is going to be like that. And they are asking you if this is A, this is B. They are asking you that the radius of wheel OB is 700. You need to find out AB. You need to find out AB. So here you will be using V is equals to R omega. Very good, Ajay. So you would be writing velocity of A, which is OA into omega. Velocity of B, that is OB into omega. Using this, you are given VA to be 80, OB to be 140. Here OB is known to us, so you can find out omega 140 divided by OB. Using this, put it here. You will be getting OA. Once you will get OA, OB minus OA is AB. Solve this one. Wonderful. I got the answer from your side. Teju, Sujesh, Kiran, Naveen, Shreyas. बहुत बढ़िया. And you would be getting the answer to be D. Very good, guys. बहुत ही बढ़िया. Advait, Manas, बहुत ही बढ़िया. Moving to question number 8. Now this is one more type, when they are asking it is rotating in anti-clockwise direction, and they are asking you everything when this is going to make an angle of 180 degree like this. I feel this type of question we have seen today morning also. Okay, so I am covering all the types of question for you guys. Okay, so this is A, B, C, sorry, A, B. This angle is 180 degree. This rotation is given to us. So you know how we have applied the eye center analysis here. Okay, in the previous question, dear, but when they are saying that A and B are located along the radius of the wheel, then obviously they are giving the velocity of the point on the wheels. Outside point, how it will be having any velocity? So it would be on the, it may not be at the diameter, but in that way, actually figure was given. Okay, that figure you have not assumed, it was given. So by mistake it was absent. So I have made the figure for you. If you see the question, they have mentioned as shown in the figure, as shown in the figure. So by mistake it was not there, so I have made it for you. Okay, yes, solve it now. Solve it now. So guys, very good questions are also about to come. We are covering all the types of questions. Yes, 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 guys. Tell me that this angle is 180 degree. You know we will be using the eye centers. And eye centers, if we will be taking in this way, link number 1, link number 2, link number 3 and link number 4. This is 1, 2. This is 2, 3. And if you remember, today only we have done it. It is 1, 4 and 1, 3 both. And this is 3, 4. Okay. So this is 1, 3 and 1, 4 both. You will apply theorem of angular velocity this time. You will say omega 2, I23, I12 is omega 3, I23, I13. So you would be finding out the omega 3, you would be getting 142.86 radians per second. And don't worry, Teju, you have sent me some good question. Do you remember? From vibrations and cam. So in the upcoming session, I would be taking those questions in the session only. Whatever the questions you guys have sent me from good topics, I have already added that. Okay? Yes. Jobin, I already told you that for that case, actually figure was given. Okay, so that is why you are getting confused there. Their figure was given, like here figure is given. So it is very much clear. So shown in the figure, rolls without sleeping. So it is a pure rolling motion. So it is a pure rolling motion. Yes. So pure rolling motion means this is the eye center. Okay, so you need to find out the velocity of point D and E. Velocity of point D and E. Shreyas is saying C, Shri Arvind is saying C. Okay, Teju is saying C. So my dear, you have seen today that also. The velocity of translation and maximum rotation is same. So here you would be having both to be added. It would be 2 times VC. Okay, if you want to find out for E, one would be like this for translation, other would be like this for rotation. Both are perpendicular. So you would be taking resultant of that. If this is VC, this is VC, automatically this is root 2 times of VC. So 2 VC and root 2 times of VC would be the right answer. Moving to question number 10, this is the relative velocity. So you can say I am taking one question of each type. One question of each type. One question of each type. Okay, here you will apply relative velocity approach. That is AB into omega 2. CD into omega 4. You need to find out angular velocity of link 4. You need to find out omega 4 in this. Yes. Solve it, guys. Faisal is saying B, Kiran is saying B, Teju is saying B. Okay, very good. So you would be saying AB is 100. So 100 into 10. Then 180 into omega 4. The answer is 5.5 radian per second. So you are finding them easy because you are knowing the concept of these questions. Okay, like in vibration, I am going to have some difficult questions. There you will feel the level. Very good, Venu, SK. So what would be the answer for this? This is also easy. You need to check correct direction for Coriolis. Correct direction for Coriolis. Yes, solve it. Very good. Okay. So they are asking which of the figures shows wrong directions. Okay. So you know this omega is anti-clockwise. So this is the direction. This is the direction of velocity. If I will be rotating it anti-clockwise, this is anti-clockwise 90 degree. This is the direction. So this is 1, 2, 3, 4. So this is the correct direction. So if this is the correct direction, my dear, 1, 1, these two cannot be the answer. Yes, very good. So my dear, now you will say 2. Here, this is the direction of velocity. So Coriolis will come in this direction. So this is wrong. So wherever 2 is there, that can be correct. Here and here. Then we will see 3. This is clockwise. So this is Coriolis direction. That is also correct. So this is also wrong. Answer would be A. बहुत बढ़िया. So this was the twist in this question. This is from Clint's construction. I told you now that I have covered all the topic. So don't feel that sir is doing easy question. Now this is the time for exam. So I am taking the exam level questions. Okay. But in Flywheel you guys have problems. So I have taken some very difficult questions and which will just clear your concept. Difficult means they will clear your concepts only. Okay. Yes. So guys, we are asking about which quadrilateral represent the acceleration. Options are there in front of you. Sujit says B, Teju says D. Okay, let us see then. They are asking you quadrilateral represent acceleration. Now Teju says C, Manas says C. And okay, first of all, my dear, you will be taking this radius and you would be plotting with this radius a circle. Okay, then taking this diameter, you would be plotting a circle like this. So you would be aware, I will be making the circle again, don't worry. So this is one of the circle like this. Another circle would be like this. Like this. So this is the line joining. Like this. So my dear, if you want to identify the exact quadrilateral, that is going to be OP OPST, OPST, OPST. B is the right answer. From where W is coming, bhai? OPST is the right answer. Don't you remember, this is the triangle and this is the rectangle. This component is radial. This is radial and this is radial for connecting rod. This is tangential for connecting rod and this is for slider. Very good. बहुत बढ़िया. Moving further, guys. So moving further, guys. Okay. So guys, we have seen almost 12 questions. After 3 to 4 more questions, we are going to have some wonderful, you can say lengthy type of good flywheel questions also. Yes, moving further. Can you solve this one? Can you solve this one? You need to find out the length of fixed link. Length of fixed link is this. To find out this is 40. This we don't know. And this is 30. To find out this, you can use the velocity ratio. What do you mean by velocity ratio? You know that linear velocity of B and C are going to be same. So this is O. OB into omega 2. CD into omega 4. This is going to be equal. And omega CD is longer. So omega 2 by omega 4 will be 2. You can write it as CD by AB. Use it and get the answer. Use it and get the answer. बहुत ही बढ़िया भाई तेजू, बहुत ही बढ़िया. This is a good question. Can come to confuse you. So the answer for this is going to be what? अरे भाई, this is 30, this is also 30. 30, 40, 50. Answer is D for this. This is easy question. Now one question from offset. Now one question from offset. Wonderful. Wonderful. Now this question is from offset. Let us see how many are able to solve this question correctly. This is the real paper. Okay, you know that if we are having this as crank, this connecting rod, this as slider. So this offset is given. We have two positions, you know that. One position is with this. This is crank. This is going to be the connecting rod. Okay. This is going to be the connecting rod. This will give you first position S1. Second position of slider would be this S2. You need to find out this stroke length. Okay, so you can see that this is one triangle and this is the second triangle. So if you see, this is L minus R, this is offset X, this is L plus R, this is offset X. So this is O. You can find out OS1 to be equals to L minus R ka square minus X ka square. You can write OS2 to be L plus R ka square minus X ka square. And stroke length is very easy to calculate. S1 S2 will be OS2 minus OS1. Solve it. So Manas is saying, Naveen is saying, Jobin is saying, Shreyas, Kiran and Teju is saying the answer to be C, 104.6 centimeters. Wonderful. Everybody is getting the same. 104 0.65. Wonderful. Moving further. This is a very easy question. Let us see how many of you are able to answer it. Very easy question, but a new type of question. For the previous question, I feel for the previous Venu, the answer will be this 104.6. You will find out from this OS1, from this OS2, and OS2 minus OS1 will be your answer. So answer will be 104. Very good, very good. Okay. So if you see this question number 15, the answer would be 1, because you know this BC link is in pure translation. So you see any point on this link, it would be having same linear velocity. So velocity of E and velocity of F are going to be same. So the ratio of their velocity is going to be 1. The answer will be 1 for this. बहुत ही बढ़िया भाई. Faisal, बहुत ही बढ़िया. Now this is from Coriolis, and after that we have questions from Flywheels, guys. So be ready for Flywheel questions. One question from degree of freedom is also there. Yes, solve it. What would be the answer for this one? V is given to us. Omega is given to us. So you need to find out Coriolis. Coriolis is 2V omega. 2V omega. So this is velocity, this is omega. Very good. SK is saying C. Ajay B, Teju B, Faisal B, Jobin B, Kiran C, Ajay B, Shreyas and Manas B. So you would be having 2 into velocity is 10, omega is also 2. Answer is 40. First of all, either B or C is the answer. Then my dear, this is omega. Omega is anticlockwise. So this is the velocity. Anticlockwise will be this. This is the direction of Coriolis. So anticlockwise, when we are going to say the 40 meter per second square, it is, we are getting it by rotating it in the direction of omega. Okay, so the answer would be B or C, in the direction opposite to omega. Yes. So direction of omega is this actually, if you are talking about direction. So when he is asking about the sense, so sense of rotation is anticlockwise. Sense of rotation is anticlockwise. Okay. Sense of rotation will be anticlockwise. When we are getting 40 meter per second square, how we are getting it? Direction of velocity was like this. We are rotating this velocity vector in the sense of omega. Sense of omega was anticlockwise. So we are rotating it anticlockwise like this. Okay. So I feel it would be acting in the direction. Actually, it should be perpendicular to the direction, perpendicular to the sense of omega. Actually, this wording is not good. It should be perpendicular in the sense of omega. And if you see B option, it is showing direction opposite. So direction is given by right hand thumb rule. So nothing has to be taken from direction. It is actually asking you how we decide the direction. We are deciding the direction with the help of omega sense. So we are rotating it by 90 degree in the sense of omega. So answer would be C in that case also. Okay. So moving further to the last degree of freedom. After this we have flywheel questions. After this we have flywheel questions. Yes, Venu, Manas, Shreyas, Naveen, Sujeesh, Faisal, tell me about this. After this we have flywheel questions. So this session is not going to be more than 1 hour. We would be completing it fastly. Wonderful. What is the degree of freedom? Here many students are making mistake. That's why I have considered it also to tell you, like you were asking, sir, how we will get to know which motion is a redundant motion, which is not. So here you will get an idea which motion is redundant, which is not. Okay. So if you will see, this is link number 1, link number 2, link number 3, link number 4, and link number 1. So the number of links are equals to 4. If you see, this is a binary joint. This is a binary joint. This is a binary joint and this is a higher pair. So 1, 2, 3. Binary joints are 3. Higher pair is 1. This motion is not redundant motion, because when you would be giving pure rolling motion to this, obviously your mechanism output motion will happen. Okay, if we would be having the connection in this way, just imagine if this connection would be like in this way, like this. Means if the motion of this roller is pure rotation, not pure rolling, then the motion of this would be a redundant motion. But here if it would be moving in this way, obviously your entire mechanism will run. So this motion is not redundant, it is a part of mechanism. So you will be saying there is no redundant motion. Fr is 0. So degree of freedom would be 3 into 4 minus 1 minus 2 into 3 minus 1. So you would be getting 9 minus 6 minus 1. Degree of freedom would be 2. Answer would be C for this. Very good. Okay. Very good. So I feel this type of question generally students are having doubt. Now it is the first flywheel question. Continuous 5 question we are having for flywheel, and we will solve them for today and I will leave you. Okay. So this was for the checking of all the concepts. A horizontal cross compound steam engine developed 300 kilowatt at 90 rpm. So we have power 300 kilojoule per second and rpm is 90 revolution per minute. Why I am writing this? It will help you to solve. Fluctuation of speed is to be kept within. CS will be, it is 0.5, 2 into 0.5 by 100. You would be getting, I feel, okay, it is percentage, so we will multiply it with the 100, na? Or divide it by 100. 0.5%. You can find out the value for this. It would be 0.01. So you would be having, once again, if the mean speed and coefficient of fluctuation of energy found from the turning moment diagram is to be, okay, a coefficient of fluctuation of energy is found to be 0.1. What will be the coefficient of speed and the maximum fluctuation of energy of the flywheel? Okay, fluctuation of speed that we have already found out, and you also find out fluctuation of energy of the flywheel. Okay guys, so this is the question. We are starting with easy question here. So my dear, first of all, we need to see the definition of CE. Some people are giving the answer to be C. Okay, we will see that. First of all, CE is defined as delta E divided by E mean. E mean can be written as work done per unit cycle. Work done in a cycle is said to be mean energy. So my dear, work done in a cycle can also be written as work done in joule per second into you need to find out work done by second. Joule per second is the power. This is the power. If you will be dividing it with the N, this is RPM, revolution per minute. Okay. If you want to have revolution per second, you have to divide it by 60. Now my dear, after dividing it with the 60, it would also be becoming revolution per second. It is joule per second. So answer would be coming out to be joule per revolution. So to get the answer work done in a cycle, you just need to do one thing. It is nothing but P into 60 divided by N. That is work done in a cycle, which is the value of E mean. CE is known to us. You need to find out delta E. Now please solve it. I have given you the hint how to solve it. Yes, Teju. Okay, you have already given the answer. So the answer for this would be 20 kilonewton meter. First of all, these two are wrong because CS value you got it. After that, you have found out and we got it the value. Now we are moving to a very, very good question. This is the best question because it covers every concept you want. Like you were asking, na, sir, can we be asked for the formula of pi dt? Yes, this question have that. A punching press makes 25 holes of 20 mm diameter. Today, Jabir also have asked a question, sir, what if frictional losses are given? So here frictional losses are also given. This question covers everything. That's why I have taken this. Okay. So if you see this, first of all, you know that we need to find out the shear area, which is pi dt. You can find out it. Then they are saying that this causes variation in speed. Okay. The punching operation takes 2 seconds per hole. 6 Newton meter of work is required. 6 Newton meter of work is required for 1 mm square. So work done per mm square is given as 6 Newton meter. So if you want to find out the work done per hole, it is equals to 6 into shear area. This would be having the units of Newton meter. So this is the work need for one hole. This is work needed for one hole. Very good, Teju. So this is the work needed for one hole. This is the work needed for one hole. Once you will be getting work needed for one hole, then my dear, they are saying that frictional losses are 15%. It means they need to produce 15% more than that. So if you are going to say what is the theory, what should be the actual work done by the motor, that should be work done which is required per hole divided by 0.85. Okay, for finding out actual, I will divide it by 0.85 because this should be 85% of this because 15% are getting lost. So this is how you will check it. So once we have seen work done, actually it is work done per hole by 0.85 and you would be getting the actual work done from this. Once you will get the actual work done from this, this is the work done per hole. Then you will find out work done per hole actual. You will be multiplying it with the number of holes per second, and this will give you the power in joules per second. So when you would be doing that, you would be getting the answer to be 2.772 kilowatts. So I feel you are very good in this question. Then what is the problem, Teju? I didn't get, because this is one of the difficult most question from this topic. Okay, Manas, Shreyas, Kiran, बहुत बढ़िया. So answer would be 2.772. One more question we have. A mass of flywheel of steam engine is 2000 kg. This is the mass of flywheel. Has a radius of gyration k. This is the torque. You can write torque is I into alpha. So m k square alpha. From here you can find out the angular acceleration. This is also a new type of question. Very good, Teju. So I have taken 2 to 3 questions in this session from monsoon series, because in monsoon series I have taken some wonderful questions. So I have taken those questions also to give you some more confidence. Very good, Jobin. Okay, majority of you are saying B to be the answer, but some of you are saying D also. Teju, here your practice is not working properly. Okay, so answer would be B here. 1.125 radians per second square. Okay, B would be the right answer for this. Very good, Faisal. बहुत बढ़िया, Jubin, Sujish. I feel, Teju, you have seen that. Okay. Answer would be coming out to be D. Moving to the next question. Moving to the next question. A mass of flywheel of a steam engine of 200 kg, everything is same. What will be the speed and kinetic energy of flywheel after 10 seconds? What will be the speed and kinetic energy after 10 seconds? So like you know, V is equals to U plus AT. We can write omega final is equals to omega initial plus alpha times T. Alpha you have just calculated. And you also know kinetic energy is half I omega square. Okay. So first of all, find out omega after 10 seconds. Alpha is known to us. Is it clear? Starting torque is given to you and it is starting from zero speed. So I feel you can find out it. Okay, fine, Teju. I was just kidding. So when you are going to find out this omega initial is 0. Then angular acceleration was 1.125. Time is 10 ka square. So you would be getting the value of omega final. That will give you the kinetic energy. Once you will get this, you will be getting 107.9. So this is only one option. A is correct. You need not to find out the kinetic energy. You need not to find out the kinetic energy. Okay. Wonderful. Okay, guys. Very good, Ajay. So we got A. Now these are some questions solved I have taken for you, and just to tell you some of the question how to solve it. Like you guys were having the doubts in flywheel, so I have taken some good questions. Sri Arvind, it means you need to work more on the type of question in flywheel. Although the gate questions are very easy, but still we have to prepare for the difficult ones. A flywheel with a mass of 4 kg has a radius of gyration to be 1.8 meter. What is the additional energy stored in the flywheel for an increase in speed from 325 to 350 rpm? So my dear, you know radius of gyration is given to be 1.8 meter. I is mk square. Omega 1 and omega 2 you can find out because n are given to us. Delta E would be E2 minus E1. You know the formula for energy. Just by putting the formula, you can find out the change of energy. You can try this question. Don't see the solution. Okay, this is just I am showing you for the purpose that type of questions in the flywheel can be of this type as well. Yes. Anybody have any doubt into this? Shall we move on? Yes, I am having two more such solutions questions. This is just to show you how to solve this type of question. To save your time, I have already put it the solution. Okay? Very good. Yes, Teju, is it fine? Yes, Teju, is it fine? Now see this question. Without looking at the solution, you can try this. Punching press is required to punch 30 mm diameter hole in a plate of 20 mm thickness. I feel this is the same or different. Okay, the similar question, but it is different question. You try this because answer you need to find out. Answer is not there in this slide. So you can solve it and get the answer. You need to determine the mass of the flywheel having radius of gyration to be 1 meter. Solve this question by yourself. Jobin, actually in the previous question, we have done it alpha t square. Sorry, okay, not t square, it would be t, alpha t. Alpha t will come, okay? Solve this question, I need answer from your side. A punching press is to be punched. You can see first of all dia and T are given to you. So you would be finding out energy by the similar formula. This would be the energy you will be getting. Now he is saying it requires 6 Newton meter of energy per mm square sheared area if punching takes place 1/10 of a second. So they are giving the punching time to be 1/10 of the second. And they are saying that 20 holes per minute. So 20 holes per minute means the cycle time. 20 holes per minute means the cycle time. 60 seconds में 20 holes, so 3 seconds per hole. This is the cycle time. Cycle time is 3 seconds. Okay, so we got the cycle time. Power rating is energy but a cycle time. This is energy, this is cycle time. You can find out this. Once you will get, this is the total energy required per unit time is, this is the power rating. So we got the power rating. Now for punching you can find out E1, you can find out flywheel energy, delta E you can find out. Then you can find out mass. Solve this. This is the last question for today. Then I will leave you guys. Just solve it and give me the answer. So as we have covered less topics today, but I have taught you everything in a great detail. It was a marathon session, but it was like a detailed discussion. Everything I have explained in that much detail, which was definitely helping you even if you forget the concepts. Next session we will try to keep slightly on the faster side and we will try to cover all your weak areas. Solve it and get the answer. Yes. Give the answer for this. Okay, Faisal. If you want, I will share 10-12 more questions. Okay. So there are, even I will try to send it with solution. Okay. Because with solution will give you better idea. Okay. So that you shall not be depending on me. I will be sharing. First solve this one. Get me the answer. Tell me the answer. You got power rating here. From here you can find out motor and flywheel. Delta you can find out. From delta you can find out mass because radius of gyration is given to us. Okay. Speeds are already mentioned, I feel so. 160, 140 RPMs are given to you. Tell me guys. Yes. Solution is just in front of you. Yes, Teju, Jobin, Ajay, Shreyas, are you solving it or not? Okay, 997.2, 321.65. Any other answer? Teju's answer is correct. Teju's answer is correct. 322 kg is the answer. Very good, Teju. 320 kg will be the answer. Okay. So I feel now everybody got this type of question. Still I will be sharing 10-12 more questions from this. Okay. And you will just try this with the solution I will be sharing. Nahi, Jobin. How you will be finding out here omega mean? This 160 to 140 are given to find out omega mean and CS. Arey bhai, this is in RPM. You will be finding out omega max as 2 pi n max by 60. You will find out omega mean 2 pi n mean by 60. Okay, then CS would be delta n upon n mean. So that would be required, na Jobin? You got it, Jobin? You would be requiring these formulas. You would be requiring these value for omega mean and CS here. Then only you will be able to find out the value, find out the solution. Is it clear for everyone? Jubin, you got it or not? Please tell me that. Yes. So don't worry. Now I am leaving you. Have complete sleep. We are going to meet on 12th of January for the second part. Okay. We will be starting with governors, cam, okay, and gyro, gear, like that. So be ready for that. And I would be taking very good questions there. I know major problem is questions there. So goodbye guys for this session. Good night. Thanks for joining again. You guys are always coming to the sessions. Thanks for your love and support. Good night. Goodbye. I will share this PDF. Goodbye. Sujeesh, I will share that as well. Just like and share the session before leaving.